There we go. We are recording that. And now we're up here. And then here's the part. This is the part that I don't know if this is going to work. I should be able to pick this up. Actually, it'd be great if somebody here could get on the Teams meeting. That'd be great. Just so somebody in here can see if this is working. This is a first. You're on, and that's what it looks like, okay? And now, does it stay like that when I do this? Yay! Because now I can write all over it. Yee! Okay, so cool. Proving identities part 2. So now that we have, hopefully you all watched the video and yesterday, and you saw that we now have a whole new set of identities. If you have your formula sheet from the beginning of the year, yours is pink, right? Do you still have your pink formula sheet? And you wondered what the heck all those formulas are? We haven't really used, there's this great big long formula sheet, we've barely used any of it. Well now, a good half of that formula sheet is just this lesson. Half angle formulas, double angle formulas. You don't have to memorize any of them. What you have to be able to do is you have to be able to use them. I had this conversation with the class yesterday, so people who are listening at home are like, oh crap, he's saying the same stuff, isn't he boring? But I wish we had the time in this course to actually show you where those formulas come from, to prove them, to derive all those formulas. But it's not really part of the curriculum. Here in the curriculum, it's just use them. And we have to kind of think that, you know, we're doing grade 12 math, pre-calculus math, we're preparing you for university math. But you know, university math kind of goes in a couple of directions. A couple is a small number. It goes in lots of directions. But the two main directions it goes is, well, what about the people who are just going to study math? Right? It's kind of like ELA. Most people end up being writers or using writing. I think math's the same way. Most people end up in the sciences. They're using math. But then there's the people who study math itself, kind of like there's people who study languages, linguists or whatever, right? There's probably a fancier word than linguist, but you get the idea. What about the people who actually study what math is and where it comes from? Those people, if you ever get a chance to take a number theory course or like a nature of math course, even a math history course, yes, there are such things, they're fun, and you get the chance to actually prove where all of these formulas come from. The closest we come to that is, I guess I kind of showed you where sine squared plus cos squared equals 1 comes from, right? Because it comes from Pythagoras. But all these other crazy formulas, if you're looking at your formula sheet, they're all derivable. They all come from logic and reason, and you could show algebraically where they come from. Some of them you actually need calculus to prove why they exist. But if you ever get a chance to take a course like that, oh, it's all kinds of fun. For us, it's more, do I recognize when to use it? That's kind of, one of the key skills of math is the ability to recognize the situation. So here's my situation. I have to prove that the left side equals the right side. Okay, how are we going to do that? Well, I said last time we were together and I introduced proofs and stuff, I said that you should only take one side. But you know, I am going to kind of maybe on scrap paper over here, I'm going to say, well, I actually know that cotangent minus cosecant on the left-hand side, that's 1 over tan minus 1 over, now which one's cosecant? Is that sine or cos? It's sine, good. So that's really what the left-hand side actually is. So that's my target, and I could even break it down more. Tangent is sine over cos, so this is cosine over sine. So this is actually my goal. I'm going to take the right-hand side, which is definitely the more complicated side, and I hope to get to here. So that's my goal. All right, any thoughts? Any ideas? Oh, anybody in this pile of papers? Hang on, I might have to give some people stuff. Okay, that's not you. That's not you. Daniel, you must have a slot 5 spare because I have your timetable here. And Yao. Whose last name is Yao? Jing Yi. It's obviously not the first name I'm familiar with, but I remember that. It must be the other group. Okay, so then it's just Daniel. Here's your semester 2 timetable, Daniel. Do you? It didn't end up in my mailbox. Did it maybe end up in your box? Who teacher mailbox? Oh, then probably in their mailbox. Okay, anyway. So we're on part 2 of proving identities. Okay, sorry about that, people at home. Let's get started. Oh, I need my fancy pen. All right, fancy pen. All right, here we go. So I'm going to always kind of keep in mind that that's my goal over here. I want to get to this. But to do that, let's see, what are we going to do? Well, sine 2 theta, you don't have any choice, right? Sine 2 theta only has one thing it can simplify to. So I'm going to simplify that. I'm going to replace it with 2. Which one am I doing here? Oh, I'm on the wrong one. This is cotangent. That's page 16? Oh, well, never mind. This is good. This is the page I want it to be on, right? You're done the page before this, right? Yeah, okay. All right. I'm looking at the wrong page from here. My pages aren't even numbered the same as yours. Whatever. Okay, sine 2 theta is 2 sine theta cos theta. Right? Is that legible? And, okay, now the top, let's have a look at this before we replace cos 2 theta. What can I replace it with? Well, if you look at your formula list, there's 3 different things that cos 2 theta is. If you take a look at your formula list, you'll see 3 different things you could use. Which one do we want? Let's see. I'm looking at my list here. I don't have these memorized either. So cos 2 theta could be cos squared minus sine squared. It could be 1 minus 2 sine squared. And it can be cos squared minus, or 2 cos squared minus 1. All right, I'm thinking ahead, and here's what I'm thinking. Notice these 2 denominators have to be sine. So I kind of need to find out, oh, and by the way, I've realized I've forgotten to finish this. This part was right here, plus sine theta. There we go. There. All right, what I kind of need to do is I need to get rid of this cos. I also kind of need to get rid of this 2. So I think what I might have to do here is I might use the one that is 2 cos squared theta minus 1. And there we have it. There's my right-hand side. I've replaced cos 2 theta with this thing. And I'm ready to move on. Okay. Would it help if I rewrote that in an order that you might be more familiar with? You know what? Now that I think about this, I think I might change my mind. I just realized that I am approaching this from the wrong angle. Sine is what I want to get rid of on the bottom. Or no, sorry, cos. Oh, no, I'm doing this right. Cosine is what I want to get rid of. I'm sorry. I just convinced myself I was wrong for a second. Okay, anybody see what we're going to do here? Factorizing. Yes, this is going to be a factoring. Turn off the lights so you can see the screen a little better. Notice the top is a trinomial. I think about it like that's 2x squared minus x minus 1. And the bottom has a common factor. So I am going to drop this pen. There. I am going to factor. So when I factor, here's what it's going to look like. The top is going to be 2 cos theta, cos theta. Now, how do I break up the 1? Remember, multiply 2 things to get negative 1. They have to be positive and negative 1. Which one do I want? I want the negative 1 over here, so that 2 times negative 1 makes negative 2, but then plus 1 gets me that term in the middle. Then down here, I can factor out sine theta. If I factor out sine theta, look what I get. Question from Alina. Nope. Because, FOIL it out. 2 cos theta times negative 1 is negative 2 cos theta plus 1 cos theta. Negative 2 plus 1 is negative 1. Think that through. It wouldn't cancel. It would leave behind a negative 1 cos theta, which is what I want. That's what it is. Okay, we're almost done, actually, because check this out. And I've accomplished my goal. Remember, my goal was I didn't want any cosine on the bottom. I only wanted sine. There it is. I have nothing but sine. In fact, okay, now here's where our advanced technique has to come in. I would like to move this. Oh, there we go, and give myself more room. This is cool. I'm really enjoying this new toy that the school division bought me. Give them props. I complain a lot about my bosses, but when they do something nice, I should give them credit here. This is a very nice machine they've given me here. All right, so now what? Well, now it looks like this. Let's rewrite what it looks like without all the stuff that we just canceled in the way. Okay, remember, let's just, mind if I roll back? Remember what we're going towards, what our goal is? Our goal is that. Can you see that? Come on. In here? How do I get there? That's right. Basically, you undo your common denominator. So you basically say that this is cos theta over sine theta minus 1 over sine theta. And now we've hit what we wanted to hit. This thing is cotangent theta. This thing is cosecant theta, which equals the left-hand side. Proven. So there's number 1. We got to use our fancy new double angle identity. Any questions on how I did that? People at home, feel free to turn on your mic and ask. Is there any question how I did that? Stephen and Mon, does this still look like what it's supposed to look like? And I guess I never asked you, how's sound? Can you hear me in there? Yeah, we're good? All right. I can scroll any which way you like, I think. There? Further up? There? We're still having a hard time getting from this line to this line, I assume. Oh, wait. I pointed things you can't see me pointing. Is there a pointer I can use? I don't know if there's a pointer. Anybody know? Is there like a cursor?
Is it the one beside the plus on beside your pens?
This thing?
Yeah.
No. Maybe I have to select without the pen. No. No. Oh, wait a minute. What's this thing? Ooh. Okay. Ah! And now why can I hear me? Oh, because somebody turned on their mic. Hi, whoever turned on your mic. Unless you're asking me a question, please mute yourself. Thank you. There must be a pointer in here somewhere. Extend the pen library, this plus? No. You? No. 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 Draw. Insert? No. Oh well. I'll Google that later on my prep today. Alright, for now ooh, I can highlight. I'll do a highlight. So I think, ooh, look at all my choices. I think, oh, it's not working though. Oh, now it's the pen, right? Oh yeah, it's the pen, not my finger. So I think what Alina's asking as I play with technology is how does this become this? Right? Is that basically your problem? Would it help, just using some scrap work over here, would it help if you just thought of it as x's? That's right. it has to multiply, no, it has to multiply to be -1. And there's only one way to do that, +1 and -1, right? And then 2 is only 2 times 1 or 1 times 2. So which combination, either the 2x here or the 2x there, would give me a -1 in the middle? Think that through. This number times this number is that number. This number times this number is that number. And then the middle is the addition of this product and that product. Right? That's how factoring works. So how do I put, I only have two choices. I have 2x and x. That's all I've got. Which one of these goes into this spot? Notice it has to be the 2x. Because if I put the 2x here on the other spot, notice I'd get a plus x when I multiplied it out instead of a minus. You good now? Okay, because I want to move on. Yay. Okay, now, once again, I need to move things around. I think if I just do that, yes. In fact, I can probably scroll this up. I'm going to move stuff around. Oop, that didn't work. See, now I'm moving the whole screen. Why is that happening? There we go. Move down. Move down. People at home are like, wow, this is exciting. I'm watching him moving things around. I'll get better at this as time goes on. And click on there, and then I don't want that. There we go. Okay. All right. Everybody on number 2? And of course, I don't know why I just wrote statement and reason. That's not what I want. Erase. Erase. Left-hand side, right-hand side, right? Left-hand side, right-hand side. Okay, so what is 1 minus tan squared theta? What is the more complicated side here? Gee, on the one hand, it kind of might be the left-hand side. But on the other hand, I have 3 different things I can replace cos 2 theta with. So, I don't know, what do you think? Which way do you want to go here? All right, why don't we play with the left-hand side first? Okay, one way or the other, this has to get, the left-hand side has to get simpler. What can I do to get myself to cosine? Well, I can change 1 minus tan squared theta into 1 minus sine squared over cos squared. Let's do that. So this is 1 minus sine squared theta over cos squared theta. And I can do the same thing to the bottom. 1 plus sine squared theta over cos squared theta. And I lost my squared. There we go. Now what? Well, obviously the right-hand side is much simpler looking. So once again, I kind of have to simplify this mess. So why don't I make it into 2 simpler fractions? Let's find a common denominator. The common denominator on this top part is cos squared theta. So this is going to be cos squared theta minus sine squared theta all over cos squared theta. And I'm going to do the same thing to the bottom. So that's this 1 becomes cos over cos, so cos squared theta plus sine squared theta over cos squared theta. And do you see where I'm going with this? This is what I kind of saw coming as I was doing this. Do you see where this is going? I actually see the answer already. I've got 4 steps in my head. Again, it's like playing chess. I see the next 4 moves. I'll start from the end. Cos squared theta minus sine squared theta is cos 2 theta. That's my last step. What's the step before that? The step before that, what do I know, highlighter, about this? That's 1. What happens when I take this divide here and change it to times the reciprocal? It's going to cancel the cosquared thetas. There's my moves. So now all I have to do is execute those moves. So, for starters, I need more room. Move that down, move this down. You're laughing at me because I'm finding this slow. Again, I'll get better. There we go. Okay, so back to here. So I'm going to, first of all, I'm going to change this to cos squared theta minus sine squared theta all over cos squared theta. And instead of divide by a fraction, I'm going to times with the times, by the reciprocal. So, you can cancel factors. And I know that this whole thing here is 1. So on my next line, I have cos squared theta minus sine squared theta over 1. I'm not going to bother writing over 1, which is equal to, check your formula sheet, cos 2 theta, which equals the right-hand side. Could I have done this from the other side and expanded this on the or this cos 2 theta on the other side? Probably. But that was the method that came to me when I looked at it. That was the part I figured out. What's Evo thinking? Yeah? So you decided you were going to use that one? Okay. Go for it. See if you can make yourself a proof. I'm not going to go through this one again, but I could. There's probably 10 ways I could do this one. Because look at cos 2 theta alone has 3 different identities I could substitute in. Right? You know, another thing I was thinking of, let me just go back to the beginning and give you another hint. Another thing I was thinking of is, I actually do know something about 1 plus tan squared theta. Right? Go back to your first round of trig identities on page 4. What do you know about tan squared theta plus 1? It's secant squared theta. And secant is 1 over cos. Ah, cos. I probably could have gone that way and made a proof out of it. So, people want to say, but what's the right way to do it? Well, it isn't the right way. You can try to find the most efficient way. What's the way to do it in the fewest number of moves? Any Rubik's Cube fans here? Remember, it wasn't even that long ago, maybe 10 years ago, maybe a little more, maybe more like 15 years ago, they finally, Rubik's Cubes have been around since the 70s. They finally discovered God's number 15 years ago. Are you familiar with God's number on the Rubik's Cube? See, if I mixed up a Rubik's Cube, Evo here might solve it in 40 moves, and Stephen might solve it in 35 moves. But there must be a most efficient way to solve it. A move being some sort of rotation of 90 degrees or more of one of the rows or columns. So there must be a most efficient way to solve it. That means there must be an absolute limit. There must be a number where you couldn't mix it up any more than that and have more moves needed to solve it. In other words, what's the most that you can mix up a Rubik's Cube? So somebody who is omnipotent, like say a god, could look at it and say, I know the smallest number of moves needed to solve this Rubik's Cube. What's the biggest number that you can mix up a Rubik's Cube? And the number is actually 20. It is impossible to mix up a Rubik's Cube more than you'd need more than 20 moves to solve it if you knew the perfect solution. It took 40 years to get that number. Computers, statisticians, combinatorial experts. They've been working on that problem a long time. Pretty cool. 20, that's hard to believe. How long does it take you? I'm one of those guys that I've memorized the formula, the algorithm for solving Rubik's Cube. You have to solve one side perfect. And then actually, I've never tried this, but you can actually close your eyes and solve it from there. You just repeat the same steps over and over and eventually it's solved. So I've got that down. So the most it takes me is maybe 3 or 4 minutes to solve Rubik's Cube. But there's people who can solve them, well, you've seen the competitions online and stuff, right? There's people who can solve them in 10 seconds. So when it comes to this particular proof, this identity, what's God's number? What way would be the smallest number of moves? Oh, I don't know. This one's pretty efficient. I like this one. but would have turning this into secant have been a shorter way? Would have expanding this into one of the three choices you have been a shorter way? I don't know. You can play with it and see. But I'm ready to move on. Let's do a different one. Okay, I got to move this around again. Okay, you get out of the way. You come back over here. That's right. I'm going to talk to them, and they'll do what I want. That's what this computer needs. It needs voice command. I feel like my grandfather. My grandfather didn't get his first vehicle till he was in his late 20s. So then it was horse and buggy. Yeah, I know. That's not that long ago, but that's the way it was in rural Manitoba. So of course he gets his first truck, and he drives it into the side of the barn. All the time screaming, "Whoa!" The car didn't respond to whoa. All right, there we go. Let's prove that one. So my left-hand side is once again cos 2 theta, and my right-hand side is another interesting-looking one. So this is cos 2 theta and 1 minus tan squared theta over secant squared theta. And now that you have seen the experience of how I did the last one, what should you be thinking? And this is totally valid. Sometimes when students ask me, how did you know to do that? I really have no response other than, because I've done this before. I mean, your personal experience is a big part of being a good problem solver. Like, oh, I've seen a problem like this before. I've got a strategy. All right, do you notice that there's one step I could do and then this becomes actually the exact same proof we just did? What can we do? Right, okay, so if I took secant squared here and I turned it into 1 plus tan squared, then it's exactly the same proof we just did. So, do you want to do the exact same proof again? What's that, sorry? Isn't it? Isn't it secant? Hang on. Oh, are we on a different question? Oh, and I just assumed they were in order? Okay, sorry. Sorry, I'm jumping to 48. Sorry, we're going to jump to 48 in your book here. Oh, by the way, you could probably guess where we got these questions from. Any guess? That's provincial exam questions. That's number 48. After you've just slogged through 47 questions, then we hit you with this bad boy. Boom! No rest for the weary. I don't know why they do that on provincial exams. They stick some of the tougher, hardest to do things at the very end. But, oh well. I guess so that people don't, if you put this as question number 1, they get people stuck on it for half an hour. Because people aren't necessarily smart at managing their time when they do a test. But anyway, okay, so are we good here? Can you see what we do here? That's one way we could do it. We could just turn that into 1 plus tan squared. Okay, I'm going to just undo that, undo. There we go. All right. I want to do it differently though. Is there something else we could do here? Let's pretend like we didn't know that solution, and let's do that piece of advice that we got on page, was it 4 or 5? Change things to sine and cos. Right? That was one of the recommended strategies. Check it out, check it out, check it out. Okay, once again, I know the left side's way simpler looking than this, so I kind of want to combine these things. I want to actually do this subtraction up here, and I actually want to do this division, which is what that fraction line is. Remember, fraction lines are divisions. So I'm going to combine the top into cos squared theta. Oops. Minus sine squared theta all over cos squared theta. And then I'll just take this, I'll do 2 steps at once here. Times, instead of dividing by this thing, I'll times by the reciprocal. And there we go. Look at that. This one was 2 steps. And then that's cos squared theta minus sine squared theta, which is cos 2 theta, which equals the left-hand side. Done. All right, any questions on how I did that one? All right, let's do the last one I have here, I think. And I think there's one more after this. I'm going to have to go get it, I think. And where did I put it? There it is. Prove the following identity. Okay, so left-hand side. So you guys are going backwards because this one was first, right? And then is there more after that? Why am I asking you? I got the booklet right in front of me. Yeah, there's a couple more after that. There's 45 and 50. Okay, so I'm going to have to go find those after. So how about while I'm looking for those, you guys can try playing with this one. So the left-hand side is, again, cos 2 theta, and the right-hand side is, whoa, cotangent squared theta minus tan squared theta, all over secant squared theta times cosecant squared theta. Yikes, and away. All right. That one looks very complicated on the right, so I think we're going to play with the right. So why don't you guys take a few minutes, guys at home, if you're still watching, take a few minutes and play with that, and see if you get anywhere. While you're doing that, I want to see if I can go get stuff while I'm in the middle of recording and sharing my screen. So let's see if I can do that. First of all, can I get back to, whoa! What does it look like on Teams right now, Stephen? Oh, so you're actually seeing my screen. You're actually seeing me play with Windows. Now, because I'm in tablet mode, I don't think I can get back to my, yeah, I can't. There's things you can't do in tablet mode, right? So I'm going to just get out of tablet mode. There we go. Oh, wow. That's interesting. Okay, I don't need that anymore. There we go. And now that I can go, now I can go to here. There we go. Now you're looking at infinity windows. But I'm going to go to here, and I'm going to go to the next page. There we go. 45 is the next one. And I'm going to snip it. Snip, snip, and copy, and then go to my notes page. And nope, it doesn't work that way. Nope, it doesn't work that way. Why is it not working? There we go. Paste. There we go, and then grab it, maybe move it down a bit, and then give myself lots more space, 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 good, and then go back to here, so go back to here, there we go, and we will snip this one. Cool, it's not that clumsy, I guess. Yep. Okay, so put that one there. Grab the other one that's on top of that little file there. Yep. Got your name on it, right? And remember, you get a calculator for that one. Okay, what am I doing wrong, guys? How come it's not coming up as paste? What's this little circle mean? Oh, is that what that is? There we go. Oh, no, it's still doing that. There we go. Paste. Weird. Okay. Okay, so here we go. All right. Okay, now that I'm back to here, I'm going to go back to tablet mode so I can write all over it. There we go. All right. Statement reason. Sorry. Left-hand side, right-hand side. There we go. Okay. Oh, right. We're doing 49 first. There we go. Okay, so. All right. You had a few minutes to play with it while I was having technical issues. What do people think? Anybody got any ideas? Where'd you go? No ideas? There's got to be some ideas. There's a few things I see that I can play with. I see that this is a difference of squares on top. Maybe I can use factoring. I see that there is a cotangent squared and a tangent squared. There's a relationship between cotangent and tangent, right? One is the reciprocal of the other. So does that help? Where do we start? Where do we go? Any ideas? Any thoughts? People at home can turn on their mic and chime in. Is there anything you see here that can help you get going on this thing? And again, remember my goal, my very final goal here is to end up at cos 2 theta. Any thoughts? What's that? Change them all to sine and cosine? Okay, let's do that. When in doubt, sine and cosines. So cotangent is cos squared over sine squared. Squared. And tangent is sine squared over cos squared. All over, all over, all over. And this is 1 over cos squared theta times 1 over sine squared theta. Okay, that's looking interesting. It's still really complicated compared to the other side, right? So I'm going to have to simplify that somehow. I think, can we simplify the top? Well, we can combine these two things here using a common denominator. So my common denominator is going to be sine squared cos squared. So that means I'm timesing this one by cos over cos squared. So that's cos to the 4. And then I'm timesing this over this by sine squared, so that's sine to the 4, all over sine squared, cos squared. And while I'm at it, why don't I times by the reciprocal of this denominator? And here, that happened. That's nice. But boy, I'm left with a power of 4. What am I going to do with that? What are we going to do with that? We can change it to powers of 2 because it is a difference of squares. So it is, open a bracket, cos squared theta plus sine squared theta, and cos squared theta minus sine squared theta. And believe it or not, we are actually at our answer. Do you see it now? Can you see the next 2 steps? This is 1, and this is sine 2, or is cos 2 theta. That's a happy face, because I'm happy I got the left-hand side. All right, cool. Let's do the same thing. 45. What are you thinking? I'm thinking the left-hand side. No, I'm thinking the right-hand side is more complicated. It's got a cos 2 theta in there. Yeah, it's got a cos 2 theta. So let's do that. Let's do the right-hand side. So I'm going to take the right-hand side. Sine, that's 2 minus 2 sine squared theta over cos 2 theta. Now, okay, let's think this through. Yeah, I can factor a 2 out of here and make that a cos squared theta because it'd be 1 minus sine squared theta. I also noticed that I need tangent on the bottom. What do I know about tangent? Tangent is, there's a relationship between tangent and secant. And secant's 1 over cos. So I might change this. I might change this to something that's going to leave me cos. By the way, there's a couple of cos 2. Remember what the cos 2 thetas can look like again. Here, maybe I'll write them down. My 3 choices for cos 2 theta are cos 2 theta can equal one of 3 things. It can equal the one that we've hit a couple times here, cos squared minus sine squared. So we've had that one happen twice. But we have these guys too. Oh, oops. 2 cos squared theta minus 1. So this guy here is kind of attractive because it would give me that 1 minus that I need over there. So I might go with that. I don't know, 1 minus 2 sine squared theta? Is that the right way to go? Well, when in doubt, you can always try it, and if it doesn't work, do something else later. So let's try that. I'm going to move this down. I'm going to move this down. I said I'm going to move you down. Down, down. Not the whole screen, just you. There we go. There we go. Give ourselves room to work. Okay, so like I was saying, I think I might change cos 2 theta. First, I'm going to factor this. So that's 2, 1 minus sine squared theta. And that is, actually, maybe before I change this, I'm just going to make sure that's what I want to do. Because now I have this. Now I have 2 cos squared theta over cos 2 theta. Now there's people who might go, oh, you can cancel those. No, you can't. This is a theta, this is a 2 theta. Those are not like terms. They don't divide each other. They're not the same number. But now again, okay, let me go back here. What will get me, which one of these will get me to here by plugging it in? Which one are you thinking? Oh, but I don't want to, you want to change the left side? I don't want to change the left side. I want to get to the left side. Okay, what do I got? I got the 2 that I want. Yay. I'm going to have to cancel this cos squared theta. How do I do that? What's going to cancel a cos 2 theta? Or a cos squared theta? Well, there's this. I guess I could just go with this guy. But that's not going to cancel it so much. Maybe this guy? Let's go with that guy. I'm going to go with the first one again. So this is 2 cos squared theta. I kind of have an idea brewing. Over cos squared theta minus sine squared theta. And see if you can follow what I'm about to do here. What do I know about sine squared theta? Well, I am going to times the top of this one by 1 over cos squared theta, and I'm going to times by 1 over cos squared theta. Now remember, I'm using the property of 1 here. Right? This whole big thing that's a 1. Right? So I didn't change the equation any, but look what happens now. Look at how pretty this is. This is now 2 times cos squared theta over cos squared theta, and the denominator is now cos squared theta over cos squared theta minus sine squared theta over cos squared theta. And I need more room again. Not much, though. We almost got this. 2 over 1 minus, oh, and what's this thing? I get this all the time. Mr. K, how did you know to do that? How did you know to do this? I don't know. It just sort of came to me as I was doing it. Because I've done these before. Because I know that's one of the tools in my toolbox I have. How does the carpenter know which saw to grab from the toolkit? I don't know. Because they've done the kind of project they're working on before, and they know what tool fits. I kind of looked at this and went, I need to get this thing canceled, this thing turned into a 1, and this thing turned into a tangent. What would make that happen? If they were all divided by cos theta, or cos squared theta, I should say. So that's what I did. Okay, one more. Let's give it a try. Left-hand side, right-hand side. There is only one more, right? Yeah, there's only one. So left-hand side, right-hand side. What's the more complicated side this time? I think definitely the left, right? So I'm going to start with secant x plus tan x. And we're trying to turn that, I guess I should copy this. We're trying to turn that into cos x over 1 minus sine x. All right. Well, again, I think the advice they gave us on page 5 or 6 or whatever it was is usually good advice. Let's change the left to sines and coses. So that's 1 over cos. and sine over cos. Well, now what? Well, I can make a common denominator. All right. Again, keep in your mind what we're trying to get to. We're trying to turn that left-hand side into the right-hand side, and right now it doesn't look anything like it. What would make that work? What would make that happen? Sorry, say that again, louder. What about the bottom? Replace it with what? Replace it with the bottom on the other side? I don't know what you mean by replace. I can't replace anything. I can multiply by 1. I can divide by 1. I can use an identity. Are there any identities for sine and cos? No. Sadly, there is not. But again, look at the trick I used on the last example. I used the 1 property. I want to use the 1 property again. What kind of 1 am I looking for? Any ideas? Okay. There's actually a couple ways I could approach this. I've got kind of one plan in my head right now. I want the top to be cosine. Yeah. Times the left side by 1. Okay, what's my 1 look like? That's the one! I am going to, that was exactly what I was thinking. I'm going to multiply by the conjugate of this. Of course, whatever I do to the top, I got to do to the bottom. That's what I want to do. Okay, and what's going to happen now? That's going to be 1 minus sine squared x over 1 minus sine x cos x. And what's that going to be? What do I know about 1 minus sine squared? Cos squared. And can you see it now? Was this what you were trying to say, Leanne, and I didn't understand you? No, okay, so there you go. Evil was given, thought that's what you're trying to say. But do you see how nicely this works now? Cancelling's more fun when you make noises doing it. And you get cos x all over 1 minus sine x, which is the right-hand side. That's an x, by the way. That's a terrible x. That looks like 7c. There we go. All right. There it is. You've got some like this to practice in 6.3 now. So that, let's see, that takes us to the end of page, what is it, page 19, right? Yep. And that leaves us with really one more lesson, and we're going to do the same thing tomorrow that we're doing today. I'm going to do the lesson on this thing. You guys can watch at home. I am going to post this on YouTube so that if you missed the lesson, you can still watch it. And hopefully, because I'm recording this with OBS, it should be a watchable video. I've tried recording my Teams videos, and it's just ugly. The Teams videos don't come out very good. They're choppy and laggy, and then of course as soon as somebody pops in and asks the question, well, their window comes up and suddenly my work becomes a quarter or half of the screen. So that's a drawback that I'm not a fan of recording Teams lessons. If I can't figure out a way to record it myself, I don't want Teams recording it for me. Also, I had some students say they're having a hard time getting to Microsoft Streams, which is where they save the videos, right, on the Microsoft Streams. So if I can go back to just posting things on YouTube, I think that works for everybody. Everybody can get to YouTube, right? Okay, so that's what I'm going to try to do next, is I'm going to try to post this. So I'm going to end the video, and again, to do that, I'm going to have to pick up the computer here and get out of tablet mode. And yeah, get out of tablet mode, which is good. So I'm going to get to here, and I'm going to stop recording.